Okay, welcome back to the last example on page. Let me see, page 8 in your notes. This one is supposed to give you a sideways parabola. That's what they want you to see anyway. But if you look carefully at the equation that they're giving you, just have a look at that equation right there. X is equal to 4y squared. Now, the way they've written that equation, and especially if you think back to what we did in the very first lesson in this unit, it appears that the x is the dependent variable, and the y in this case is the independent variable. And considering what we did in the very first lesson, you'd be justified in thinking that. But if you were to go along with that thinking, if you were thinking that x is your dependent variable, that would mean that the x would be the vertical axis and y would be your horizontal axis. Why is that? Because when you draw a graph, the vertical axis is supposed to represent the dependent variable. That's not what they're trying to get you to see here. If we were to go ahead with this here now, if we used x as the vertical axis, you'd actually end up with a parabola that opens upward. And that's not what they're trying to get you to see here. So here's what I'm going to suggest for this problem here, for this equation that you're trying to graph. I would rewrite that as 4y squared is equal to x. All right? Now, think of the y, even though this is not going to be a function. You'll see why in just a moment. I still want you to think of the y as being the dependent variable and x as the independent variable, which of course would mean that the y would be plotted on the vertical axis and the x would be plotted on the horizontal axis, as you typically draw a graph, okay? All right, so that's what we're going to do. I'm also going to suggest that we scale this axis. Well, actually, I'll put in the table of values first, but we're going to have to do some scaling here to get all of our points to fit. Now, one thing I want you to notice, for this particular equation, they don't give you the x values, and you work out what the y's are. This time they give you the y's, and you should work out what the x's are, because if you look at the equation again, you can see that the side containing the y is the much more complicated side. You're much better putting in a number for y and then squaring it and multiplying by 4. That will give you your x value, rather than putting in a number for x, because that's going to be a fairly complicated calculation to work out the x in that case, all right, or to work out the y. So let's go ahead. We'll put these numbers here. We'll put these values of y into the equation. If you put in -2 for y, you square that and get 4, and then you multiply that by 4, and that will give you an x value of 16. All right, so let's now put in a -1 for y. You square it, multiply by 4, and that will give you back a 4. Put in a 0 for y, and you're going to get back a 0 for x. Put in a +1 for y, and you're going to get back a +4 for x. And finally, put in a +2 for y, and you're going to get back 16. Now, you can clearly see that you're going to have to scale your x-axis because it actually goes all the way up to 16. So I'm going to suggest that we do this for our x-axis. We'll call that 4, we'll call that 8, we'll call that 12, we'll call that 16. All right, that would be an appropriate scaling. Now, the y-axis, you can still think of this as 1, 2, 3, and so on. Okay, 3. So you can leave the y scaling alone, but I'd suggest making that change to the x. So let's go ahead and plot these points. Let me see. If y is -2, that would be down here. Then x is 16. That gives you this point right there. Okay, see that? Now, if y is -1, then you get an x value of 4, which is right here. 0, 0 is the origin, of course. If y is 1, x is 4 is a point right there. You can see why this is not a function, right? Because it's going to fail the vertical line test. And not only that, from the table, you can see that one value of x, which remember now we're considering x to be the independent variable, one value of x, such as 4, actually gives you back two different y values. And that goes against the definition of a function. And finally, if y is 2, x is positive 16, and that's the point right there. So now when you draw your graph, here is your sideways parabola. Something like that right there. Okay, opening to the right. It still has a vertex. The vertex is 0, 0 this time. But now it's opening to the right. And as I said before, you can clearly see this is not a function. And in fact, if you look at the explanation down and under that problem, it clearly says, for the above example, you will notice this is not a function, but it is a relation, which is true, because it fails the vertical line test. So they clearly wanted you to have the horizontal axis being your x and the vertical axis being your y. But that would mean, again, that x is independent and y is dependent. All right? Now, domain. Because x is still the independent variable, the domain is still the x values. All right? So let's write values of x such that. Now, you look at your graph very carefully. Look at all of the points that are on that parabola and ask yourself, what x values are actually in all of those points? All right, for example, here's a point on your graph, on your parabola, that has an x value of 16. Here's another point on your parabola that has an x value of 12. If you go further to the right, way, even over here somewhere, you're just going to get bigger and bigger and bigger x values, right, as it opens up to the right. It does go to the right forever. Goes up to what we call positive infinity. But if you look at how far the graph goes to the left, now that's a different story, because, for example, here's an x value of -4 according to our scaling. Are there any points on that parabola that have an x value of -4? And the answer is no, it does not. You can look up as far as you want or down as far as you want, and you will see that there are no x values of 4. So -4. So -4 is not in your domain. One way that you can think about domain and range for a continuous graph, a continuous curve, is to just ask yourself this simple question. For domain, ask yourself how far to the right does your graph go, and how far to the left does your graph go? How far? And remember that the arrows on the end of your graph mean that they don't stop just because your graph finishes there. They actually go on forever. Well, this graph goes to the right forever, but to the left, it only goes as far as 0. All right, that's where it stops. So that would be your domain. And we would have to write the restriction in as x greater than or equal to 0. Notice it can be equal. And what kind of numbers? Well, real numbers, because it's a continuous graph. All right, all the real numbers are there. Now for the range, that's your y values, because again, remember, we're considering y to be the dependent variable. Ask yourself, how far does the graph go up? And how far does the graph go down? That's one way to think about your range. Well, remember now, this curve, it's a parabola. Like it does start to flatten out a bit, yes, but it really does go up forever, up to positive infinity. And this piece here goes down to negative infinity forever. So that means that your range, in this case, is everything, all real numbers, and we merely write y such that y belongs to the real numbers. And that would be your range. So a little bit of a tricky question, a little bit of a confusing question, actually. But the only way to get a sideways parabola, which is what they want, is to have your x-axis being the horizontal axis, which means, of course, it's the independent variable. Because when you draw a graph, remember, the vertical axis is supposed to be your dependent axis, and the horizontal axis, that's supposed to be your independent axis. So you have to make those assumptions about the original equation. Okay? One other thing before we finish here with this video. As it says below that, again, this is on page 8, you'll notice this is not a function, which is true because it fails the vertical line test, but it is a relation, okay, because it fails the vertical line test. If you have a graphing calculator, and if you wanted to actually graph this on a graphing calculator, such as the TI-84 Plus, you would actually have to enter it as two separate functions, because the TI-84 Plus will only accept an equation in the form y equals. All right. Now, remember I said back at lesson number 1 that it won't be a function anytime you end up with like y equals, and if there's any plus or minus on the right-hand side, I told you before, it will definitely not be a function, because remember, for every x, that'll give you back at least 2 y's. So you would have to actually type this into your calculator as positive square root of x over 2 and negative square root of x over 2, right? Because if you solve that equation for y, here's what you would end up with. Plus or minus the square root of x over 2. You see that? The plus or minus. That definitely means it's not a function. Okay, so I'll stop there. Look at this one carefully. Please try the practice questions on pages 9, 10, and 11. They should be relatively straightforward. Remember, you can play around with your tables of values. There's nothing that says you have to use from -2 to +2. Well, you can if you want. If you come up with a table and you're not getting enough points to actually see what the graph looks like, put some more x values in. Put a few more in and see what happens. And especially for the graph on the top of page 11, I just did that one myself well, a few months back, but this one is a cubic, so you kind of suspect you're going to get a sideways S. But it kind of requires you to scale your axes. I'm probably going to recommend you do something like this. On your x-axis, I would suggest going over 5 blocks and calling that 1, and then another 5 blocks, call that a 2, for instance, and the same thing to the left and to the right. 5 to the left, call that -1, and another 5, call that -2, and that will kind of space your graph out a bit, because it turns out that if you don't do that, your graph will be kind of squeezed into a very small space, and I don't think that's what they meant to happen here. And what about the y-axis? Well, you could leave the y-axis alone, but I would probably recommend maybe a scaling something like this. Call every block 2. So 2, 4, 6, 8. Maybe go up that far. I'll call it a half. 1. Go up 2 blocks and call that 2. Go down 2 blocks and call that -2 as well. Okay? So try that scaling there. If that doesn't work, try your own scaling. See what you can come up with. So I'll stop there, and you try those practice questions. And if you have any trouble, you let me know. Bye-bye for now.